Greetings to the physics community. Welcome back to another video where we will be talking about collisions in continuation of our discussion for momentum. In this short video, I will try to talk about one or two examples where we need to apply the principle of conservation of momentum to solve collisions problem. So let's jump right into it. So the first example goes as follows. We have a 15 kilogram medicine ball that is thrown at a velocity of 10 meters per second to a 70 kilogram person who is at rest on ice, which means the person is not moving on ice. The person catches the ball and subsequently slides with the ball across the ice. Determine the velocity of the person and the ball after the collision. Interesting. So, let's write down all the information that we have. We have the mass of the ball that is 15 kilograms, and the V of the ball is 10 meters per second, and we have a person with a mass of 70 kilograms, and this person is at rest. So if we try to draw simply this scenario, we are going to have the what I call before and after the collision. So before, on the system, what we have is the ball that is going to be moving with 10 meters per second, and we have the person with, so we have 15 kilograms ball and we have 70 kilograms person here, and this one has a velocity of 0. It's not moving, right? So it says at rest. And after, we have what? We have the person who was hit by the ball. Okay. Yes, so the person catches the ball and subsequently slides. So the person and the ball will be moving in this direction. Now, the principle of conservation of momentum simply states that the momentum of the system before the collision is going to be equal to the momentum of the system after the collision. Now let's calculate the momentums in the before and after scenario. In the before scenario, we have two objects. Now the ball will have a momentum that is going to be 15 times 10 mass times velocity, and that's going to be 1050 kilograms times meters per second. On the other hand, the person, because it's stationary, it's going to have a momentum of 0. Now the before momentum is going to be calculated by adding these two. After, we are going to have one body that is going to have a mass of 15 kilograms plus 70 kilograms, Okay, so we have 85 kilograms of this body, and it's going to be moving at a velocity v, let's call it vf as final. So the momentum of the system at the end is going to be 85 times vf. Now these two need to be equal, and it's a simple equation now. So P of the system before is equal to the P of the system after, before and after the collision. Before the collision, you had 150. And after the collision, you had 85 times Vf, because only in the first scenario before, we only had the ball moving, and in the second scenario, we only have one body, which is the combination of the person and the ball. So this one, you simply want to solve for Vf by dividing both sides by 85. We end up with a velocity of roughly 1.76 meters per second, and this is the velocity of the ball when it's held by the person after the collision.